Now we are going to use the Java example to talk about the Java OOAD programming fundamentals. We will use two Java classes, the client.java and the print client.java, to show principles of OOAD, such as inheritance, resource encapsulation, and polymorphism. Let's first take a look at the client.java. In the client.java, we define three private variable members. The private access modifier here is one way to define the resource encapsulation principles. By defining these member variables to be private, no other entity, for example, object, can access these members directly. Any other entity or object has to access these private members through predefined procedures or public access methods, such as the getID method and the setID method. Now, let's look at these two methods without the returning type. These methods are called as constructors. The constructor in the class defines what kind of object it will create. This constructor has no statement in it and usually considered as a default constructor. It will create an object with default status. This one is a user-defined constructor. If a class does not define a constructor, then the Java compiler will automatically provide a default constructor. But once Java class defines a constructor, then no more default constructor will be provided by the compiler. These methods are what we call member access methods of Java class. This print date method is a user-defined method. So far, we have introduced the resource encapsulation principle. And now we would like to talk about another OOAD principle, and let's take a look at another Java file, print client.java, which defines a child class of the client class. Please note that the print client class extends client class. This extends feature is actually the OOAD inheritance principle, and the child inherits all the public members, including variables and methods, from the parent class. For example, if I add a test method and another public method in the client class, then the print client class will be able to access the public tag method as an inheriting member. Let's look at the print client class. This is the constructor for the print class, and this is its own private members and the public methods. Please pay attention to this print date method. This print date method shares the same name and the same parameter as the print date method defined in its parent class. The client class. This feature is called method overridden, a specific relationship between child class and parent class, and one of the OOAD polymorphism mechanisms. Now, let's look at another example. I define another set thread ID method in the class, and instead of accepting integer as parameter, the method parameter is defined as void. These two set thread ID methods share the same method name, but different parameters. This feature is called as method overloading in OOAD. Please note that the method overloading takes place inside a single class, while method overridden occurs between child and parent classes. These two OOAD features are two different forms of polymorphism. Now, let's talk about how to create objects from a defined class. Please understand that a class is an abstraction of features to be defined for objects, while an object is a specific instance of class, and the object will take resource such as memory. The relationship between class and object is similar to human beings and a specific person. When we're talking about human beings, we will think about the feature of human beings, not a specific person. While we're talking about a specific person, then the person will have a specific feature values such as age, gender, height, and weight. Now, we will create an object of a parent-client class. And here we will create an object of the child parent class. Now let's create another parent client object PC2, and we set the parameter ID as 2 and the parameter size as 100. Instead of assign this object to a parent client variable, we assign it to a client object reference PC2. In this way, we actually implicitly upcasted a child parent client object to a client object. And this is just another form of polymorphism. Now, let's start to run this program and take a look at what will be the result. This child parent object has its own ID as 1, its parent ID as 0. Why? Whenever we initialize the child parent client object, actually will call the Schubert parent default constructs first. Thus, the parent ID is initialized at 0, and then initialize local child member variables based on local logic and parameters inside the constructor. Please note that child static members actually initialize before the parent constructor is called. This is critical, and we really need to understand this and remember this. Let's make a little bit change here to show something different. We will call PC2 print data method, and let's see which print data method, parent or child, will be called. The result shows that the print data method is actually called from child, the print client object, because PC2 is actually a child print client object. So this is the first part of the fundamentals of object-oriented programming.